We're asked to solve this limit as x approaches 0, and we're given that the answer is 1. So when you're given an answer, you can automatically assume that it is going to be a difficult problem, and then you need to check your answer. However, because the answer is 1, it's nice and pretty. Hopefully, we will be on the right way from the beginning, unlike in one of my previous videos. Limit as x approaches 0 of this. How are we going to solve this? If we plug in 0 right away, we would get 2 minus 2, which is 0, over, this would give me 1 plus 1 is 2 minus 2 is 0. So 0 over 0 is an indeterminate form, and hence we have to apply L'Hopital, which is taking the derivative of the numerator and the derivative of the denominator in order to solve this problem. So the derivative of 2 is simply 0, the derivative of x squared is 2x, and the derivative of minus 2 cosine x is plus 2 sine x. What is this? Plus 2 sine x. And then the derivative of the denominator is going to be e to the x minus e to the minus x, because the derivative of e to the minus x is e to the minus x times the derivative of minus x, which is minus 1, so minus e to the minus x. And then the same thing here, plus 2 sine x. If we plug in 0 in here now, we get 0 plus 0 divided by, and already 0 over anything will never give you 1, so you already know that this is not where we're supposed to be, so we're going to be applying L'Hopital once more. But just to check, then here we would get 1 minus 1 plus 0. So in fact it's still 0 over 0, it is still an indeterminate form. Oh my, I do a lot of these little dots and it annoys me, sorry. You must be annoyed too. So the limit as x approaches 0 is, we have to apply L'Hopital again. If you don't know what L'Hopital is, well, it's easy. Actually, I've said it, sorry. Just the derivative of the numerator over the derivative of the denominator. So now we're doing the same thing again, and hopefully it will work this time. There we go. So I've taken the derivative of everything again, and something tells me it will work this time, because we have 2 plus 2 cosine x, which is, since cosine of 0, when you put 0 in here, cosine of 0 is 1. So this is actually going to become 4 divided by e to the 0 is 1, e to the 0 is 1, cosine of 0 is 1, times 2 is 2, and so 1 plus 2 is 4. 4 divided by 4 is 1, and we have shown that the limit as x approaches 0 of this huge thing is in fact 1, 4 over 4. We're done.